Alright, hey folks, so we're going to go through some factoring using difference of squares. So when we expand two binomials that are the exact same except for the middle sign, we always end up with the binomial as a final product. And so in this case, this difference of squares approach is like a very specific type of problem. Okay, so we'll see here as we go through this step with FOIL how these parts, I guess, can kind of cancel each other out. So remember that factoring is the opposite of expanding, and so in order to factor binomials, we have to look at the square roots of each term, whereas before we would be looking for squares. So in order to go through this part, I guess first we just need to revisit what FOIL would look like. So remember, when you have FOIL, really here you have your first term, your outside term, your inside term, and then your last term. And so if I had, let's try something like this where we say have 2x minus 3 and 2x plus 3. We're going to go through and check out our FOIL steps for this. So our first two terms, okay, 2x times 2x will give me 4x squared. My outside and inside terms, so outside terms 2x times 3 would give me 6x, and then my inside term, negative 3 times 2x, would give me negative 6x, and then my last two terms together, negative 3 times negative 3, would give me negative 9. After that, you combine all of these terms together, so sometimes it helps just to write them all out. So I'd have 4x squared minus 6x plus 6x minus 6x minus 9. And then I can see that in this case we combine our middle terms together, but plus 6x minus 6x cancels each other out. And so really I'm left with 4x squared minus 9. So if I wanted to go from here back into this, that's where the difference of squares approach comes in. It's a very specific type of problem. So remember that when we factor, it's the opposite of expanding. So in order to factor binomials, we have to look at square roots in each term. So if I were to look here at the square root of 4 and the square root of 9, they're both, and they both just kind of happen to be perfect squares. And that's, I guess, as we factor these things, they're the opposite of doing our FOIL method. So, example 1, factor the following question. We have 25a squared minus 16b squared. Now, if we take a look at all of the terms here, 25, the square root of 25 is 5. Square root of a squared is a. The square root of 16 is 4. And the square root of b squared is b. So your brackets will be the exact same. The only difference is, did you notice from my example up here, my brackets were the exact same, but my signs were opposite of each other. And that gave me two terms that were perfect squares with a minus sign between them, which is exactly what I have here. So brackets will be the exact same, so I'm going to open up two brackets. I'm going to have 5a and 4b. I'm going to have 5a and 4b. So brackets will be exact same, except they will have opposite signs. One's a positive, one's a negative. So if I kind of follow this approach or this idea with these factoring questions, I should be able to FOIL this back out and get where I started. So 5a plus 4b and 5a minus 4b should give me back to 25a squared minus 16b squared. So if I FOIL this out, I've got my first term, which is going to be 25a squared. It's a good start. I've got my outside terms, which are going to be 5a minus 4b, so that's minus 20ab. I've got my inside terms, which in this case are going to be positive 20ab. And then I've got my last term, which is positive 4b times negative 4b, which is negative 16b squared. And then if I write out what I have here, 25a squared minus 20ab plus 20ab minus 16b squared, I can see my middle terms are exactly the same but opposite signs, so they cancel out. And what do I have left over? 25a squared minus 16b squared. And so that's how I'm going to figure out my difference of squares, because then I can compare that back to my original answer to see that I'm on the right track. So difference of squares questions, you're looking for perfect squares. Okay, that's the whole idea behind them. So as an example here, let's say we have x to the 4 minus y to the 4. Now in this case, we have to understand how our multiplication works with exponents. When we multiply exponents, they add together. And so really here, I've got a perfect square of x to the 4, because really what I have is x squared times x squared. Right? I have a perfect square because it's the same number multiplied by itself. And so that's going to be subtracted from y squared times y squared. Right? Y squared times y squared is y to the 4, because 2 plus 2 is 4. Now I have a perfect square here in each one, so I'm going to open up my two brackets. I'm going to write my beginning term, x squared. I'm going to write my final term, y squared, and I'm going to do that in each one, x squared, y squared. One's going to be a positive and the other one's going to be a negative. And then I can see, by doing the FOIL steps going through this, that when I cancel out my middle two terms, they should be the same term but have opposite signs to them. So I guess this one was the negative. X squared, y squared, and then my last term would be minus y to the 4. And so you can see right away that my middle terms are going to cancel out, and I'm going to be left with x to the 4 minus y to the 4. So if I take a look at these and they have perfect squares, then I can take them out. So for example 3 here, I'll get you to try this one out, actually this one and number 4, and come back when you're ready to give it a try and go through. Alright, so in example 3 it says, remember always check for common factors first. So in the first one, it looks like I've got a 10 that's in common in each one. And if I take a 10 out, I'm going to have x squared minus 64. Then I look at those and think, okay, that 64 has a perfect square to it. I'm going to open up my two brackets. Really, I could have kind of a bigger square bracket outside here. And then I've got my x term to start off with, my 8 term at the end, plus minus sign in the middle. And so really at the end here, I don't need the square brackets, but I mean they don't hurt to be there. I'd have x plus 8, x minus 8, and then kind of all that multiplied by 10. And again, I could FOIL out my two binomials, so basically from this step, and then I could multiply that by 10 and see that I'd end up getting back to my same answer that I started with. If I take a look at the bottom one, perfect square of 4 is 2. So let's open up our brackets. Perfect square of 4 is 2. Perfect square of y squared is y. Perfect square of 81 is 9. So it looks like I could write the same thing again, 2y and 9. One's a positive, one's a negative. And again, I could go through and I could FOIL this out and make sure that I have the right answer. And so my first two terms, 2y times 2y is 4y squared. My outside terms could be minus 18y. My inside terms could be plus 18y, which is good because they need to cancel each other out. And then my last two terms are negative 81. So if I put it together, 4y squared minus 81 with those middle terms canceling out. So a difference of squares problem is really precise, where you need two terms. They have to be perfect squares on each side, and they have to have a minus sign in the middle. So this only works when we deal with binomials, where both terms have a square root with no decimals, and the two terms get separated by a negative. So out of the ones that are here, can you spot the difference of squares problems that are there altogether? So take a second, look at them, see which ones here can I use difference of squares for. So pause, read, and come back when you're ready to go over it. All right, so if you take a look, which ones, again, we're looking for perfect squares. So looks like 4 has a perfect square, and 36 has a perfect square. So it looks like this one can be done. 4y and 6, 4y and 6, with a minus sign and a plus sign. In my next one, 15 is not a perfect square, so that one's out. 21 or 3, they're not perfect squares, so that one's out. This one has 3 terms in it, so I can't do this one either. So remember, it has to just be 2 terms. And then my last one, looks like I can do it because 9 and 100 and x squared and y squared all have perfect squares to them. And so it looks like I can have a 3x and a 10y, a 3x and a 10y. I can have a positive and a negative. And so hopefully that gives you kind of a little bit of an insight on how to do difference of squares type problems. Good luck, and let me know if you have any questions.